Now, the last section we'll look at for this is the concept of conditional independence, and we'll go through this rather quickly, but assume that we have an A and a B, two events that are independent. We can look at those in a sample space over here. And the question that we might ask is, can we still say that A and B are independent when they're conditioned on C? So the way to write this out from a mathematical perspective would be, can we say ultimately that if we add some event C, that the probability of A intersected with B conditioned on C is equal to the probability of A conditioned on C multiplied by the probability of B conditioned on C. Now, this is the equation for conditional independence. We're literally just taking our original equation for independence and adding conditions, specifically on this event C. Now, let's assume, first off, again, that these A and B events without C in the picture are independent, right? We don't necessarily need to know the distribution of the events, but now we've added a third event C. And the question is, can those events A and B, are they guaranteed to still be independent when we add the condition of C? And if we look at this graphically and we remember one of the key elements of independence from before, the answer should be popping out as a no. And the reason for that is even if A and B are independent in their current configuration, once we condition on C, we now have an event A conditioned on C and an event B conditioned on C. And in both of these situations, you'll notice that they are totally separate event spaces, that these are now disjoint. Now, again, we're assuming that A and B were independent previously, but because when we've added the condition, we've turned these into disjoint events, these are now not independent because they are disjoint events. Now, this is not necessarily a guarantee, right? There are some situations where we can condition A and B on a third event, and they will still be independent. But the fact that we can show an example like this, where two events are independent, and then when they are conditioned are no longer independent, then we can prove kind of graphically that independence does not automatically flow down when a system is conditioned on an additional event. So anytime you're looking at independence, make sure to include all of the conditions that you care about to determine that those events are truly independent when conditioned.